going to see what is the Internet of Things architecture. This architecture is about consists of 7 layers. The first one is the sensor input to the microcontroller or microprocessor, or data collections happens here. The sensors there are 3 types of sensor. Motion sensor. Motion sensor measures the change in motion as well as the orientation of the devices. There are 2 types of motion. One can observe a device linear and angular motions. The linear motion is referred to the linear displacement of the Internet of Things device, while the angular motion refers to the rotational displacement of the devices. The second one is the environmental sensors such as light sensors, pressure sensors embedded in Internet of Things device to sense the change in environment parameters in the device peripherals. The primary purpose of using environmental sensor in Internet of Things is to help device to take autonomous decision according to the change a device peripheral. For instance, environmental sensors are used in many applications to improve user experience. The third one is position sensors. This device deals with the physical position and the location of the devices. The most common position sensors used to Internet of Things devices are magnetic sensors, global positioning systems. Magnetic sensors usually used to digital compose the help to fix orientation of device display. On the other hand, the other one is processing and control action layers. Microcontroller processing, these are where the data is for processing, especially locally. Microcontrollers, ordinary or Raspberry, Linux, Android. The third layer is hardware interface layers, which is component for communications, maybe USB, serial, parallel, standard. The third layer is an interface layer through which the communication is directly taken as or going to classification for short range or low bandwidth, long range, and like Wi-Fi, Bluetooth. These are especially used for connections. The fourth one is session or message layers, where is the content like MQTT, HTTP, FTP, SFTP, SSH protocol. The other is user experience or visualization layers, technologies, object-oriented, procedures-oriented, like database management system, SQL. Finally, the 7th layer is application layers, smart home, smart city, smart agriculture, and so forth. Internet of Things ecosystem consists of web-enabled masters, smart device that uses embedded processors, sensors, and the communication hardware to collect, send, and act on the data they acquire from their environments. Internet of Things device shares sensor data they collect by connecting an Internet of Things gateway or other edge devices, where data is either sent to the cloud to be analyzed or analyzed locally. Sometimes this device communication with other related devices and act on the information they get from the one another's. Remember that Internet of Things technology is a built system capable of autonomous sensing and responding to stimuli from the real world without human interventions. We therefore need to develop process flow or definite framework over which an Internet of Things solution is built. The Internet of Things architecture to be discussed shortly generally comprised of 4 stages. The first stage is sensors and actuators. A thing in a context of Internet of Things should be equipped with sensors and actuators. This given the ability to emit, accept, and process signals. The second stage is data acquisition system. The data from the sensors start in analog, from which need to be aggregated and converted into digital stream for further processing. This stage performs this data aggregation and the conversion functions. The third stage is edge analytics or edge computing. Once Internet of Things data has been digitalized and aggregated, it may require further processing before it enters the data centers. This where edge analytics comes in. The fourth one is cloud analytics. Data that needs more in-depth processing gets forwarded to physical data centers or cloud-based systems. Here, as you see on the graph, sensor actuators, wired or wireless, internet gateway or data acquisition systems or data aggregations, HIT analytics, pre-processing, data center, cloud analytics management architectures. Most researchers agree on conventional architectures for Internet of Things that include the following layers: perception layers, network layers, and application layers. Some other latest variants, including Internet of Things latest architectures, add support layers that lays between the application layers and the network layers. Support layers consist of fog computing and cloud computing. Hence, Internet of Things architecture consists of different layers of technology supporting Internet of Things. It serves to illustrate how various technologies relate to each other and to communicate the scalability, modularity, and the configuration of Internet of Things deployment in different scenarios. The latest agreed upon Internet of Things architecture is composed of smart devices, sensors layer or perceptions, gateway on the network layers, management service layers, application layers. A smart device or sensor layers lowest layer made up of smart objects integrated with sensors. The sensors enable the interconnection of physical and the digital world, allowing real-world information to be collected and processed. Various types of sensor for different purposes. Sensors have the capacity to get measurements such as temperatures, air quality, speed, humidity, pressures, flow, movement, and electricity. Most sensors require connectivity to sensor gateways. This can be in the form of local area networks such as Ethernet, Wi-Fi connections, personal area networks such as Zigbee, Bluetooth, and ultra-wideband. For sensors that do not require connectivity to sensor aggregate their connectivity to back-end servers, application can be provided using wide area networks such as GSM, GPRS, and LTE. Sensors that use low power and low data rate connectivity typically form networks commonly known as wireless sensors networks. Massive volume gateway and the network layers, this is the second one. Massive volume of data will be produced sensors, and this requires robust and high performance wired or wireless network infrastructures as transport mediums. Current network IP-based, often tied with a very different protocol, have been used to support machine-to-machine network and their applications, with the demand needed to serve a wide range of Internet of Things service applications such as high-speed transaction services, context awareness applications. This is multiple network with various technology and access protocol are needed to work with each others in heterogeneous configurations. Any protocol that carry IP packet has advantage over all others. The connectivity requirement of Internet of Things differs so diverse that single technology cannot meet all the range, power, size, cost requirements. The importance of IP to the Internet of Things does not automatically mean that the non-IP networks are useless. It just means that non-IP networks require a gateway to reach the Internet. This network can be in the form of private, public, or hybrid models are built to support the communication requirement for latency, bandwidth, and security. Various gateway, microcontroller, microprocessor, gateway network, Wi-Fi, GSM, GPRS. A smart Internet of Things gateway is implemented to provide data processing, local web servers, and cloud connections. After gateway receives the data from the wearable sensors, it will forward the data to Internet of Things cloud for further data storage, processing, and visualizations. This layer also ensure unique addressing and routing ability to unified integration of uncountable devices in a single cooperative network. Various types of technology have contributed to this phenomenon, such as wired, wireless, and satellite technologies. The implementation of 6 low WPN or low power personal area network over IP version 6 protocol to hard IP version for unique addressing of devices also important developments. IP version 6 is a key for Internet of Things. Addressing schema provide more addressing than there are gain to send on Earth. The management service, this is the third one. The management service renders the processing of information possible through analytics, security controls, process modeling, and the management of devices. Service may include applications and the support service often provided by cloud for computing technologies. Management service layers features business and processing rule engines, support the formulation of decision logic, and trigger interactive and automated process to enable more responsive Internet of Things. Analytics. Various analytics tools are used to extract relevant information from massive amount of raw data and to be processed at much faster rate. Two types. In-memory analytics allow large volume of data to be cached in random access memory rather than stored in physical disk. Streaming analytics allow analysis of data considering data in a motion is required to be carried out in real time so that decision can be made in a matter of seconds. Data management is ability to manage data information flow. With the data management in the management service layer, information can be accessed, integrated, and controlled. Data filtering techniques such as data anonymization, data integrations, data synchronizations are used to hide the detail of information while providing only essential information that is usable for the relevant applications. Management service features security must be enforced across the whole dimension of Internet of Things architectures, right from the smart object layer all the way to the application layers. Security of the system prevents system hacking and compromising by unauthorized persons. This reduces the possibility of risky. So illustration of Internet of Things scenario, simplified representation of Internet of Things network compasses in the device gateway communication link. Internet of Things application service. Typically scenario involves this entity includes the device collecting data from an environment, temperatures, luminosity, movement, and reporting. If it's a provision entity hosting by an IoT platform service provider, the different communication technology and gateways must have means to device provisioning, administration, monitoring, diagnostic, important for traveling, replication, and corrective measures. An ideal solution will provide means for managing all devices from one dashboard. So this is the Internet of Things architecture. We're going to see